Hello everyone. So this video is the second part on the radius of curvature. If you haven't not watched the first one, so if you want, then I have put the link description below. You can check if you want. So now in that previous video, what we have did is just simply derive the formula for the radius at any point on the given function. So now recall what we have derived in the last video. It is just radius at any particular point on the curve. So just simply we understood what is the meaning of the radius of curvature at any particular point and how to determine it. So in that video we have ended with this equation for the radius of curvature. So now in this video, as I have told, we are going to plot one or two function, and we find the radius at particular point, and we can also plot the curve on the graph and also plot the corresponding circle with radius that we have find with the help of this equation. And we can also plot the circle on the graph, so you can easily understand the concept and also see what this equation actually represent in the xy plane or in the graph. So now first of all, let's assume one function. So now here, let's our first function, it is just an exponential e to the x. Now also we call this function as an y, so we can also equate equal to y. So now first of all, to find the radius of curvature r, we first of all select a point. We have to select one point on x-axis, and corresponding to that point we can get the value of y from this equation. And if once we have find the x and y coordinate of any particular point, then we can also find the radius of curvature at this particular point on the curve. That is what we are going to do. So now here, let's assume I am taking the x as in 1. So now from this function, what will be the value of y here? Simply just put the value of x here, so we are getting just e now. And now recall, the value of e is just simply 2.718. So now we have selected one point. So now to find this radius of curvature at this point, we need the first derivative of this equation, and also we need a second one. So first of all, let's find this first derivative. So I can denote it as an y prime, or also as an f of x. Now the derivative of this function is very simple. It is just simply again the same function, e to the x. And now we also need the second derivative, so let's also find it. Do not confuse with this notation. It is just simply the second derivative of this function y with respect to x. We can also write like this. So these are the different way to represent the second derivative, but they are actually the same thing. Now again we have to differentiate this function e to the x one times again. So simply we again get the same function, but now here we are interested to find the radius at this particular point 1 comma e. So we also have to find the this differentiation at this particular point to get the radius at. So let's write it here, radius at 1 comma e. So let's denote it like this. So now just simply put all the values that we have got from this two differentiation. So now let's put it here. So 1 as it is. Now here we have to square the first derivative, and here first derivative is just simply e to the x, and here we are interested at the point x equal to 1. So now just simply put here the 1 in the place of x. So simply we are getting e, and we have to square it, and also we have to raise the power 3/2. Now in the denominator we have to square this, sorry, not square, just simply put this second derivative. So now again we get simply e to the x, and again x is 1, so simply 1. So now put the value of e, which is 2.718. and just simplify it. So let's do it. What we are getting after the simplification. Now it is just simply 8.9387. Now, so we have find out the radius at this particular point on this curve here. This is the our curve, which is just e to the x. So now, but to plot the circle on the xy plane with this radius, we also need the coordinate of the center of this circle. So now, to do so, we have to first of all plot this function here in the rough. So now, first of all, let draw it here. So now my function is exponential. So we know it is increasing like that, like this. Okay, but now here, let's suppose here I have x, it is an x-axis, and here it is y. So suppose I have one here. So this is the corresponding point here, e 1 comma e. So this is the point that at which we have find out this radius, which is 8.9387. So now suppose if if I assume let center of this circle at this point is lies at somewhere here. So let's call it O here. So now if I draw the line here, so it is just a radius that we have find out, just simply 8.9387. So now to find the center of this circle here, first of all we have to find the angle, this radius which is making with this horizontal line x-axis, this line x-axis. So now to do so, let first of all draw a tangent at this point. Let's call it point A. So now if I draw the tangent at this point A, so it will look like this. It is just simply touch the curve at a point A, and it's continue like this. It is just simply a line, straight line. So now we can also draw horizontal line here, which is pass from this point A like this. So now if I am interested in finding this angle, because it is formed between this radius and this horizontal line, so let's call it theta prime. And now if I easily find this angle, how? Because this angle is just simply the angle which is this tangent, this yellow tangent, this one, it is a tangent make with this horizontal line. Here it is an x-axis. So how to find it? Just we know at the any particular point the slope on any curve here. This is our function e to the x. So we can say slope at any point, it's just the first derivative of function, and we also know slope is nothing but just simply tan of theta. So we can say we can equate this slope, it is just tan of theta equal to first derivative, and here theta is just simply this angle which this tangent at this particular point is make with this horizontal line. So now we can find this value theta from just simply using the first derivative of this function e to the x. Now but here we need this angle. So now recall this radius will also perpendicular with this tangent at this particular point. If it's represent a circle with a center at O and this radius, then it must be a perpendicular with this tangent on the circle. So now we can say this angle will be 90. So on the back side we also got the angle 90. So now from this symmetry we can say if this angle is theta with this yellow line and this green dotted line, let's extend this line also. Now if this angle is theta, then we can say from symmetry this angle will also theta, because they are between the same line but they are just extending in the back direction. So we can say here, or we can write one equation which is just simply theta prime plus theta gives a 90-degree, because it is an right angle. So now let's first of all find the value of theta. So here we can easily find. So let's first of all we have find out the first derivative. It is just again e to the x, because here our function is exponential. So let write it here. Tan of theta is just simply e to the x. But here we are finding at the point 1 comma e. So let's put the value of x here. So we can say tan of theta is just simply e. So now let's get the value of theta from the equation, this equation. So now apply tan inverse on the both the side and you just simply get the value of theta, which is 69.80 degree. So now we have find out the value of theta. Just put it here and get the value of this theta prime. So we can say that it is just 90 minus this 69.80. So we got the value of this angle also, which is 20.90 degree. So now we have find out the this angle theta also, this one, and this we also know the radius. So what we have next to do is just simply use trigonometry to find the value of this coordinate x and y. So let's make a triangle which is a right angle. So let's call its point P. So we can say triangle OPA is a right angle here, this triangle, which is formed between these three vertices here. So now we can easily find this horizontal distance and vertical distance. So now first of all let's find this vertical distance here. Let's call it, let's say, capital Q. So now we simply use the sine of theta, because sine of theta prime, because we know that value of theta prime and also we know the value of r. So let's use it here. So we can say sine of theta prime is just simply this front side, which is we have assumed q, which is unknown. We have to determine it and divide by this hypotenuse, which is just simply the radius, and we got the value of radius is 8.9387. Now if we solve for the value of q, let's do it quickly. So we are getting q as in 3.085, but now we need this point, sorry, a coordinate y coordinate of this point O. So now we are actually at this point and we are measuring this distance from P to O, but we need the distance from this origin to locate the center of this circle, which is located at this point O, and we have to find the value of x and y. So we have to use, sorry, we have to add this distance, this amount of distance, because we are already at this point and we are measuring the vertical distance from this P point. So here the this y distance is nothing but just simply the value of function at this point, and here the point is 1 comma e. So we can simply say that y distance here is e. So we have to add e in this number, so we can easily find the y coordinate of this circle. So let's add it. So we are getting 5.80 as in y coordinate of the circle. So we have find out the y coordinate. We also need the x coordinate of this circle. So now use the cosine function. So we can say cosine of this theta prime is just simply the this side, which is PA. Let's call it as in capital P, divided by this R. Again it is. So now let's find value of P. Now we got the value of P is just simply 8.3894. Now again look at the figure. We are measuring the value from this point A and we got the this horizontal distance. We got the this length PA, but we need the length from this origin here. So again we have to subtract this horizontal distance, this one, this amount, because we are at here already at A. So we can say this distance is nothing but simply just 1. So let's subtract 1 from this value. So what we are getting is just simply 7.3894. But now to locate this point in this xy plane. Also recall that if this distance is 7 point something, then it must be in the second quadrant because we have located origin at this point. So this point must be in the second quadrant. So we can say here the value of x is negative. So let's make it negative. So y will remain as positive as it is. So now we have find out the center of circle. So let's write center of circle. It is just minus 7.3894, and here the y coordinate is just simply 5.80. So now we have find out the center of circle, and we also know the radius, which is just simply 8.9387. So now what we have to do, just write the equation of this circle with this center and this radius. So use this general equation of this circle equal to r square. Now here h and k is the center of the particular circle. So now let's write equation for this circle here. So what I am getting is just simply here we got the plus sign because he x is h is a minus here, whole square plus y minus 5.18 square equal to, we have to square the radius. So now we have find out the equation of circle, and we already have the equation of function, which is just e to the x. So now let's move to the calculator and plot this function. First of all, e to the x, and we have to then plot this circle and look at how the graph is looking like. So now here you can see I have plotted. So here this red curve, it is just nothing but our function, which is e to the x. So this red curve here, it is just our exponential function, and here this circle in the blue color, it is the circle with the radius 8.9378 with center at this point. Now you can see now this black dot is corresponding to the our selected point, which is 1 comma e. So now you can see how this curve and circle at this point will merge in together. So now let's zoom it so you can easily see. Now see at very near to this black point, which is our selected point. So now this red curve and the this circle will exactly merge in together. So now we cannot, we can say that this a little portion of this red curve, it is just simply the arc of this bigger circle. Now in the same way we can describe the whole curve with the different circle, like at any point, like this point, at any other point we can find any particular circle with some particular radius. So now you can easily understood what we have did in the previous one with the help of calculus to derive this radius of circle at any point, and we are calling it just simply as an radius of curvature at any particular point. So now let's again zoom little bit. So now again look how this function. So now see very near to this black point. So okay, we have understood one function. So now let's take other function, which is polynomial. So let's write here our second function. It is just an polynomial x cubed by 3 minus x plus 3. Now use the same formula for the radius of curvature, which is, sorry, now we have to find the first derivative, which is just simply x square minus 1. We have also need the second derivative, it is just simply 2x. Now again we have to select one point, on the xy axis. So let's, I am selecting x as in 1. So now put x as in 1 in this equation, and what we are getting, let's check. So we are getting the value of y is just simply 2.33 and 3. So we can write it like this. So now in the same way we can find the radius radius at this point, which is 1 comma 2.33. With the help of this equation we have to put the value of this first derivative and second derivative from this, and we can find the radius. Now in the same way we have done in the last function, we have to find the center of this particular circle, and we have to write in the circle equation, and we have to draw this function. And now let's draw also this function, this polynomial, this one, and the corresponding circle with the radius. Now you can easily find the value of this parameter h, k and r, and let's simply put direct this function. So now I have put it the I have plotted the polynomial in the red color, which is the exactly same that we have taken in the lecture. So now I have also drawn the corresponding circle at this point, and this green point is corresponding to the our selected point, which is 1 comma 2.33. So now you can again see how this circle will exactly merge in with this curve with very near to this green point. So now let's again zoom it. So now look at the portion at here. You can see that this circle, sorry, this red curve very near to this green point can be expressed as the small arc of this circle with some particular radius. So now you can easily describe any point, like at this point also you can find other circle with some center and some particular radius. Now every point you can easily find with the help of equation that we have understood in the previous one. So that's it, we have completed this second video also. I hope you enjoy it, and thanks again for watching this video.